Hi guys and welcome to yet another devcast. Today I'm going to talk about one of my newest tools and its first major update, and that is Voxelizer and the version 0.2.0. There are a lot of feedbacks I got for this internally and externally. There were a lot of things that I had in my own to-do list that didn't come from a feedback, and I'm building this tool up to solve multiple things I was targeting, from authoring voxel things to actually running voxel scenes in runtime and so on. There's still a ton of features that I want to add, and some of them are crucial ones like serialization of data and so on. But I hope this update will push it to more of you guys that wanted to try it in a different scenarios than just taking a single asset and trying the voxelization on. So this will also cover the features that I added for the minor update that was 0.1.1, because I didn't do a video about that. I just mentioned it on LinkedIn, I think. I didn't even put it to Reddit. So this will cover all those features as well. So let's start. So this is the original scene with the single asset. As you can see right away, I did a lot of refactoring about the UI to make it more streamlined, make it more readable. It is in line with my other tools like Dash or Instance Painter and so on, where now I'm trying to put all these UI utils and skins together so I can build more more tools with a similar UI. So what are the new features? Let's cover the features from the 0.11 first, and that is I added the other types of voxelizations, because there was this SDF, which is a single distance field type of voxelization, where it basically generates a single distance field from the source mesh and then voxelize on it. We create a binary grid from that. Uh, it is very fast voxelization, but some type of geometries don't really like that. They are not that, how to say it. It may differ from what you would expect from that output, and also there are some boundary issues for a different geometry, also issues for open geometry and so on. So I added other voxelization algorithms that will output a different result, but it may be something that you are looking for. But these are way slower than the signal distance field voxelization, so just keep that in mind. So let's just try it out. I need to hide the source. Okay, so this is the grid voxelization, and when you compare it to the SDF, you can see that it's a different result from that, but it may be something that you are looking for. And finally, there is a winning, which is based on winning number of the polygon. It's again a different voxelization. You can see that these two are very similar on this geometry. They are exactly the same, whereas the signal distance field is it tends to like inflate the model as well. If you are interested in more details how these types of voxelizations work, just let me know. I'm not going to cover the algorithms behind that and how they actually work, because it's not really important for this update and for the workflow with that with this tool. But if you are interested in more technical views into the voxelization and how it's generated, just let me know, and I may do a video about that as well. Also, I changed the way how the voxel size is handled, because there was this relative way in the initial release of the tool, which will basically you select the density type, which is what's the which dimension should be taken into account when calculating the voxel density. And this is the diagonal, which is from here to basically somewhere here. And then you were setting the density, how many voxels should be in that diagonal, and then you voxelized. Whereas now you can set the voxel size type to absolute, and you can just specify the voxel size. This is way better if you have a different objects with, and it is pretty hard to calculate the exact same voxel size for a different sized object. So you can now specify with absolute values what's the size of the voxel, and all your assets, all your objects will have the same size of the voxel, which is what you probably want in most of the cases anyway. So let's go to the you know, other things that were added. Let me go over the list. Okay, there is now custom voxel mesh type. The initial release had only this, which is a cube. Is a very specific cube that use non-interpolated non-interpolators for fragment shaders and so on. So it's a very specific cube that is generated internally. But now you can select the voxel mesh type. So let's try. There is a quad which additionally to generating a quad geo for the voxels, it automatically enables billboarding for the shader. So now not only these are quads, but they will rotate towards the camera. So it's automatically billboarded. As you can see, it disabled the shadow because generating shadows from billboards is not really what you want. It would seem funny. There are different approaches that I may choose to follow shadows for billboarded shaders. Something like a different shadowcaster geometry or a specific shader that will billboard shadows forward light vector and rendering forward the camera vector. So there will be, I don't know how it will look, but those are the lists that I have in my to-do that I may try. Additionally, now you can specify the voxel scale inside the renderer. This is actually a material property as well. So if you, for example, use a custom shader or a custom material for the voxels, it will check that if there is a support for voxel scale, and it will tell you in a help box that a warning that there is no support for voxel scale. But these materials and shaders that I provide support voxel scaling, so you can just select an arbitrary arbitrary size for the final voxels. This is a different this is a different thing from this voxel size, because this is how the grid is calculated. And this is purely for rendering. So if you, for example, use these quads and you see these spaces there, even though the geo is in a grid sized on this voxel size, you may want a different scale inside the rendering for a specific geometry. You can also specify a custom voxel. As you can see, it automatically switched. If you go from quad to cube or a custom geometry, it will automatically switch back to not use billboarding. You can explicitly use billboarding for a custom geometry if you want, but this is what the renderer assumes that you don't really want to. And now I set the voxel mesh type to custom, and as you can see, I have this voxel mesh there, which is a sphere, which is a unity sphere, and now all the voxels are unity spheres, so you can pretty much use any voxel mesh. Now I use the voxel scale as well. And you can use, so let me see, I have a different different things here. Let's see, let's try for example this fence for some reason, and as you can see now all the voxels are these fence from Bitgam. Not sure how would you use that, but you can, for example, you have a bones there, and you can put a pillar from bones. Actually, I may do that, and I will add a custom scale offset and maybe a rotation offset, so I can generate pillars from bones just for that. I don't think the voxelizer was targeted towards that. It's more of a machina way where I can generate like pillars of skeleton or of bones for a random dungeon. But I may do that just for this to have fun. Okay, let's switch to the cube and disable culling anyway. You can enable culling. This was in the initial release as well. Even though it is enabled, you don't have any culling shader specified. It will not work. It will not cull. This now checks for culling, and internally I also removed the CPU pre-cull pass, which I am using to based on cell size on grids to pre-cull stuff and sort it in memory just to have a more efficient culling before it is sent to GPU. I disabled that. I'm working on that. It will be refactored. I'm working on that together with my instance painter to choose similar approaches to culling. But for now, I disabled the CPU precull, and as you can use GPU culling if you have a compute shader that supports it. I provided that it's inside the repository, so you can use it if you want to. But that's all for now for culling. Okay, now let's go to some new features, and let's switch a scene for the voxelizer to a different source. Let me show the source scene for that. As you remember from the previous version, from the initial version, you could only specify a single renderer that would be used for voxelization. Now you can actually specify any transform, and it will go through that transform over all its children and voxelize all its children. And you can also specify a mask. For example, if you have some type of depth meshes or some things in your scene that you don't really want to voxelize, you can specify a mask for that. So now it will voxelize all the mesh renderers inside that transform. So let's run it. Let's set a bigger voxel. Now hide the source. As you can see, now it voxelized all the meshes here. We can go even more, no problem. All the meshes here, and I can show you some new features that I added. Firstly, there is this voxel bake transform. So by default, from the previous version, there was no baking. So this is what was the default setting if you used the previous voxelizer without this feature. What I added for this setting also is a cache. Cache is now only supported only if you don't bake any transforms, because it is easy to generate a cache, because it is basically a dictionary for a mesh that can be referenced through Unity. Whereas if I was baking it, I would need to generate a cache for all differently transformed meshes. I can do that. I'm working on it. It's my to-do list. But for now, the cache was added for just unbaked transforms. So if I voxelize it, you can see that the first mesh was voxelized using the algorithm, whereas all the other meshes, since it's the same mesh, were only read from the already saved cache, and this cache was used to generate the binary grids for the output voxels. So you can generate voxelized scene for a scene where meshes are repeating very fast. So you can disable the cache even for non-baking, but why would you do that? I think it's always useful to have it enabled. If I go to a different transform baking, it will automatically disable the cache. So what's the voxel bake transform settings? As you can see here, where we didn't generate or bake any transforms, these voxels are bigger than these voxels. Why? Because we have a voxel size of 0.5. These are smaller than these voxels. It is because this was generated, the grid for that was generated for this mesh, which is the mesh that you have on your, it's the asset actually from Bitgame here. And the voxels are generated based on that mesh and not how the mesh looks in the scene or how the mesh is transformed. So the transform for the scale is happening after the voxelization. So these voxels are scaled and therefore the voxel itself will be bigger than the other voxels where the asset is scaled down and so on. This, however, uh, there is an option to actually invalidate the voxel or the rendered voxel based on the actual transforms from the original geometry, and that's additional thing that I added to the voxelizer. So if you don't bake any transforms and you go, and I can go here to, for example, this mesh, which is this one on the original scene, and I move it, the voxelized geometry will move as well, because I added a job system that invalidates all the matrices for the voxels inside that mesh based on the transform invalidation. So even if I scale it, it will also scale, or if I rotate it, it will also rotate. So, and that's if you don't bake any transforms. Now there are other options, and I may add more of them, but these were the make most sense. And that is, let's start with the last one, scale, rotation, and position, which will basically bake all the transforms. So it will generate the transform the mesh into the local transform coordinates and then run the voxelization. So let's just try it. And now, as you can see, it looks completely different because this mesh was rotated, scaled down, and the voxelization is now happening on that transformed mesh. So, and as you can see here, whereas this is completely flat, this is not so, because the voxelization is happening on the rotated plate, on the rotated geometry. So it will look like this. Now, if I wanted to move the mesh, it will not move because the link was broken. The transform will not invalidate the final voxel geometry. And there are also things that you may bake where you still want to preserve some of that invalidation or the original transformation, whereas bake some of them. So let's try scale rotation. Let's voxelize. This basically looks the same because because the position doesn't change how the voxelized object actually look once it's baked. It's just the position on the in the world. But now, if I change this position of the original object, I can work with the positioning of the assets. So you can work inside the level and so on. Finally, I can try to just voxelize and bake scaling, and this will really help if I want to have uniform voxel sizes, because now you can see that these voxels are the same size as these voxels and also the same size of these voxels, because the scaling of the asset was baked, and the voxel grid was generated based on the scaled up. So this pillar contains a lot more voxels than this pillar, whereas it before it was the same, it just scaled post voxel. And now I have this nice geo based with baked scaling, and I can again move it around. I can even rotate it now because those those transforms were not baked into. So that's what all this baking is about. You can play with it. I'm very curious about feedback on this because there are different approaches. How would you want to generate your levels in your game, for example, or your voxel assets in the scenes? So just let me know. And this is all for the 0.2.0 version. I will update it. It's already updated on GitHub. I will also update it in the binary ego package repository, so you can install it using a package manager. And the next step up will be serialization of the data, because as you know, this data doesn't serialize, so it doesn't preserve. For example, during if I run this game now, it will not be there because I'm using native containers for the job system and also and so on. I already solved this, for example, in Instance Painter, where I have different data for a serialization pass and different data for a runtime pass. I will solve it for this in the next version of the Voxelizer as well. Currently, if you wanted to have this in your game, you would need to voxelize at runtime. So you can do all this setup, but then call voxelize at runtime and it will voxelize. But not all of you want this. You want the data pre-cached in your editor time, and then you want to run the game with already voxelized data. So that will be covered in the next version. And as usual, any feedback is welcome. And thanks for watching. Thank you, guys.